Prudent Scholars in association with Goa Headmasters Association.
Education is not about learning of facts, but training your mind to think. And I'm sure most of us have forgotten about this, because what we do is, whenever something is taught to us, we always learn just the fact. For example, if I would teach you a plus b the whole square, you would say a square plus 2ab plus b square, and you have learnt it. But why? Why am I learning it? What is the reason? Is something that we tend to forget. So that's the reason I've thought of putting this quote, telling you that education is not just about learning of facts, but training your mind to think. And which is the best subject that can help you do it? And it is mathematics. Because here, you don't by heart anything, but you make yourself aware about those facts, but yet making you to think. So let's start with today's lesson. Now, here I have a picture of a tower, and there's a parent and a child who have come to visit this place. And the child is very excited to see the top of this tower and have the entire view, how high it is and what it looks like to be on top. So he tells his father, let's go inside and find out how to go on top. So they go and then finally get inside. But after a while, they come back saying that the receptionist inside tells them that you're not allowed to get in and you can't watch it today because probably it is closed or something like that. But the child is very hesitant. He doesn't want to go home without watching, going on top of this tower. And he wants, he's very stubborn not to go home, and he wants to watch it today and wants to see how high it is. So as this argument with the father is going on, he removes his, a laser light that he had, and he points it up and just plays around with it. The moment the father sees this laser light, he gets an idea and he tells his son, Baba, I can't take you on top today, but I will definitely tell you what is the height of the star. And so he removes his phone, and then with some mathematical knowledge that he had, he tries to do a little bit of math, and then he tells what is the height of the tower. So are you also thinking, like, how did he manage just with one laser light and a little bit of mathematics, he was able to tell the height of the tower? And end of this video, I'm sure you will also be able to do all this. So we are going to study something called as Introduction to Trigonometry. And this is a chapter that you have not studied in the past, not even the letters to make words. Okay, so it is a completely new chapter for you, and I would want 100% attention from your side so that you are able to learn it very well. My name is Joel, and let's start today's class. In case you are getting stuck somewhere and you're not able to concentrate, not able to understand, then I would say you can visit my Instagram channel, get in touch with me. That's the QR code for my YouTube channel where I make videos and put, so you are able to study it well. In case you want to get in touch, you can do that, but please do not waste time writing everything. Just watch, concentrate, learn, and then trust me, you will be good at trigonometry. Here I have a basket, and in that basket there are sticks like this. Okay. Now what I'm going to do is, there are a number of sticks, so I'll make triangles out of it, and this is what will happen. Now there are different kinds of triangles over there, But one that we are interested is this triangle. And that's a right angle triangle. Now I'm telling you that it's a right angle triangle. Okay. Now, what is the speciality about right angle triangle is that one of the angle will be always 90 degrees. And once you know that one angle is 90, the side exactly in front of that 90-degree angle will be called as hypotenuse. So I have marked 90 degrees over there, and the side exactly opposite to that is the yellow color one, will be called as hypotenuse. Simple, right? You have studied this in triangles and even in your 7th standard, 8th standard and so on. So in a right angle triangle, the exact opposite side is a hypotenuse. So thing that you should keep in mind is that whenever we are dealing with trigonometry, we are talking only about right angle triangles. Now, can trigonometry be used for other triangles? You can, but in this course of the entire chapter, we are not going to bother about any other triangle, but we are going to only look at right angle triangles. So first thing, keep in mind right angle triangles. Next, I'm looking at this entire triangle from this angle which you can see in red. Okay. Now, whenever I mark an angle, the side exactly in front of it, so whatever angle I mark, the side in front of it will be called as opposite. So you can see I have marked it over there, both the colors are red. So angle and exactly in front of it will be called as opposite. The next, once you know the angle, the side next to it will be called as adjacent. So the one in green will be called as adjacent. So that's it. So in a right angle triangle, we have named those sides as hypotenuse, opposite and adjacent. Now there will be some students who will say that I don't want to look at this triangle from the angle that is marked in red, but I want to look at it from the one that is marked in blue. So will the opposite, adjacent and hypotenuse remain the same? Hypotenuse will definitely remain the same because it is not based on the angle that you choose, but it is based on the right angle that is taken. So right angle in front of it, hypotenuse. The other sides will definitely change. So the angle that is marked exactly in front of it will be called as opposite. So this adjacent will not be adjacent anymore, but it will be opposite. So once you mark the angle, the side in front of it will be called as opposite. And the side next to the angle will be called as adjacent. So I hope this part is clear. We have dealt with two important things now. We are looking at right angle triangles and we are looking at the sides. And once you know these two things, okay, that hypotenuse, opposite and adjacent, you are able to identify which side is what, trigonometry will become simple. Okay. So based on this information, we can say these are new words for you right now. So sine, cosine and tangent. Now these are three trigonometric functions. Okay. Now what is a function then? The one which you go for your party, right? That function? No. Sine, cosine and tangent are nothing but trigonometric function. Simple example to make you understand would be, say I have a wall and I fix a door. Okay. And this door is not just fixed anywhere, right? It is fixed with those hinges that are there. Based on that, it is able to move. So these trigonometric functions are nothing but a joining of the wall and the door. The hinges become like that, right? So the hinges join the wall and the door together. Same way, trigonometric functions relate or join the angle and the sides. So there is a kind of a relationship that is created with these trigonometric functions. Without these trigonometric functions, in a triangle, angles is one entity, sides is another entity. There is no connection between the sides and the angles. Trigonometric functions help you relate them together. So I hope this part is clear till here. If you have, still having a doubt, please go back a little bit of this video and then check it out. Okay. So 3 trigonometric functions: sine, cosine, tangent. Are these the only 3? No. I can also have cotangent, secant, and cosecant. Okay. Now, if you notice very carefully, these trigonometric functions, the first 3 and the next 3 that I have given, have same colors, right? So, sine and cosecant is having the same color, cosine and secant, and tangent and cotangent. Now, why are they having the same color? It is because sine, cosine, and tangent are nothing but inverse function of these. What is an inverse function? If if you're standing straight, trigonometric function. If I hold you, by your leg and turn you, upside down, then it becomes an inverse function, something like that. So, if I would say sine and cosine, cosecant, how are they related? Just 1 upon sine will be cosecant. Okay. How is cosecant related to sine? 1 upon cosecant will be equal to sine. Simple as that. So, if I would say cotangent and tangent, how are they related? Can you think how exactly? So, it would be cotangent and tangent are related as 1 upon tangent will be equal to cotangent, or cosine will be equal to 1 upon secant. So, inverse function means all you have to do is put 1 upon, that's it. Okay. So, in total we have 6 trigonometric functions, but we mostly look at it in terms of the first 3: sine, cosine, tangent. Now this name look a little bit complicated, right? Why you want to study all this cosecant and secant and tangent and sine and too much, right? So let's give them a little smaller names. Like you have in a class you have certain students whose name is a very big one, and then you make it Zhuangzin will become Joe. Okay, so like that, sine, cosine, tangent can be written in a short way by writing it as but before I tell you how it is, what you call them, please observe the way it is written, because I would definitely want you to remember them immediately as it is going on. So it's not difficult. So just go on with the flow and you will understand. Say it with me and then you'll learn it. So we have sine, cos, tan, cot, sec, cosec. Okay. So we have gone with the flow of saying sine, cos, tan, cot, sec, cosec. Okay. So the entire 6 trigonometric functions are written this way. Okay. Now I also told you that the trigonometric function relates to the sides and the angle, right? So the sides, which are how they related, is O, A, O, A, H, H. Okay. Please, just pause this video right now and learn this thing exactly how I have told you, and the next part will be very simple. So sine, cos, tan, cot, sec, cosec, OA, OA, HH. You can learn it in a different way as well, but I find it the most simplest one is only because, I was taught this when I was studying. My teacher taught it to me, and if I can still remember it without any, problem, that means there is something in that which can help you remember. So just learn that, and will be, easy to go ahead with the problem. So sine, cos, tan, cot, sec, cosec, OA, OA, HH. Now, if you have learned this by now, then we can start solving a problem. Now, in triangle PQR, angle Q is equal to 90 degrees. If cos R is equal to 7 upon 9, find the length of PQ, tan R and cosec R. So, first thing that we want to do over here is write this or draw a figure. So we can write once we have drawn the figure, the angle Q is told to us is 90 degrees, right? So we'll mark the angle 90 first. Okay, PQR is the entire triangle. P and R can be placed interchangeably anywhere, but Q is 90, so it has to be given the 90 degree angle. Then we will write this. Cos R is equal to 7 upon 9. Okay, it is given in the question, so exactly the same thing we have written. Now, what is the meaning of cos R? Cos is the trigonometric function. R is from where you are looking at it. Okay, simple to understand. A trigonometric function without an angle, it doesn't have any meaning. Okay, so you need an angle, to give you some information. So cos R is equal to 7 upon 9 only means that I am looking from the vertex R in respect to trigonometric function cos. Okay, so we require this. We have already studied this, right, in the previous part. So sin cos 10, cot sec, cosec, OA, OA, HH. Now, what is cos? Cos is nothing but adjacent upon hypotenuse. So we are looking from point R, and cos is nothing but adjacent upon hypotenuse. So I can write this as adjacent upon hypotenuse. So cos is nothing but adjacent upon hypotenuse, which means when I am looking from point R, which is marked already in the triangle, my adjacent becomes 7, the next one, right, was adjacent to the angle, and hypotenuse will become 9. So let us take those values over there, and it would become something like this. So from the angle that is marked, that side, right, is the adjacent, and the hypotenuse is 9. But don't you think, like, I have given you just a number, but number should always be, accompanied with some measurement to it. If I would draw it on a piece of paper, then I would draw 7 centimeters, 9 centimeters, and so on, right? So here, just think of it that I'm giving some measurement as K. Now, K is not a measurement, but this method, entire solving, is called as K method. That's the reason I put K. And since it's a ratio actually doesn't have units, but I can also have another triangle where the hypotenuse is 18 and the other side is 14. So again the ratio will be the same. But are those triangles similar, right? So triangle chapter, so the triangles can be different. That's the reason we will just write K as, thinking of it as units, but it is not a unit. It's just because it is a ratio, we write K. Now, find the length of PQ. In the question it is given, find the length of PQ. Now, PQ is one of the side. It is a right angle. So we can use Pythagorean theorem to find out the side. So I'll write the Pythagorean theorem. Hypotenuse square is equal to square of the other two sides added. Okay, so here I have written PR square is equal to PQ square plus QR square. So what I will do now is substitute the values. So PR is, okay, let's write the signs first, and PR is 9K, right? So I will just write 9K, and since it is PR square, all I will do is put a square for it. PQ is something I need to find out, so that will be written as it is, and QR is given to us as 7K. So QR square will be 7K the whole square. So something like this. Now, what is 9K square? 9 square will become 81, and K into multiplied by K will become K square, is equal to PQ square is something that is, I don't know any value, right, for it, and 7K square will become 49K square. Now what I want to do is, now you can see it is 81K square and 49K square, right? So just get those numbers on one side and subtract them. So let me write this back again, and let's make some space, right, for 49. So it would become 81 will come a little at the side. This 49 from the right hand side moves to the left hand side. So there is a change of sign. So positive will become negative. Now once you subtract this, so 81 chocolates minus 49 chocolates. After subtracting, you will get PQ square to be 32K square. Now let us, but are we asked to find out what is the length of PQ square? No, we are asked only about PQ, right? So all I have to do is take a root. Now, what is, I mean, the simple words of finding a root is that, root is that it looks like an X, right? Cutting chopper. So take it and chop it into half. But when you're halving it, making it into half, it's not divided by 2, but those two numbers divided equally, multiplied should give you 32. So is there any number that I can do that? Frankly speaking, it will be a decimal number, right? So mathematically easily we can't find. So we'll just keep it as root 32. But k square can be separated equally as k and k, because k multiplied by k will become k square. I hope this part is clear till here. So we have root 32k is equal to PQ. Now what I will do is, since I found out this answer is PQ is root 32k, I will write it in the triangle. So I've written it over there. Now I have, for that entire triangle, I have all the 3 sides found. Okay. Now I can easily find out what is 10R. So in that table, the orange color table that you can see, 10 is nothing but opposite upon adjacent. From where are we looking? We are looking from point R. So from R when you are looking, so 10R, let me write it first. So 10R or 10 will be opposite upon adjacent, and 10R will be opposite upon adjacent. So I've just written it over here. Please make sure you write the the formula kind of thing first, and then you write the value. Otherwise they might just minus your half mark for not writing it. So write this thing down. Now from R when you look, okay, opposite is nothing but root 32k. So let us write that. Okay. From R when you look, adjacent is nothing but 7k. Okay, and it's upon, so I'll write that. Now k and k can be cancelled off, so it disappears, and the value of 10R will come as root 32 upon 7. Okay. Then we are asked to find out what is the value of cosec R. So cosec R will be from the table. Sine and cosec are inverse trigonometric functions, right? So cosec will be nothing but hypotenuse upon opposite. Okay, so cosec R will be hypotenuse upon opposite, because the inverse function, right? I told you are standing and then turn in ulta, so that is it, right? So hypotenuse upon opposite. So here let us write that. From where are we looking? We are looking from point R only. So from R when you look, hypotenuse is nothing but 9k, okay, and opposite from there will become root 32k. K and k will get cancelled, and you will get cosec R to be 9 upon root 32. I hope this entire problem is clear. If you want, you can take a screenshot right now and copy it later. So first we are finding one of the side by using Pythagoras theorem, and then we are using that table to find out the other trigonometric function, that is 10R in this case and cosec R. Okay, let us solve another problem. Okay, so let us check another problem. In triangle ABC, angle B is 90 degrees. If sine C is 7 upon 25, find the length of BC, cot C and cosec A. So first let's draw a figure. So we have a figure. Angle B is told to us as right angle, so let us mark angle B, and C and A can be marked anywhere. Okay. Then sine C is equal to 7 upon 25. So I will write that first. So what is it telling us? Again, sine is a trigonometric function, C is telling us that we are looking at sine from point C. Okay, so when that is done, we'll require this table also. So I'll just keep it at the side. And sine C. So I've marked the angle for you. From where are we looking at? Now, from that point, sine is what? Opposite upon hypotenuse. So from there, here sine is opposite upon hypotenuse. So let us take it to this point. So sine C is 7 upon 25, which is opposite upon hypotenuse. Which means when I am looking from point C, opposite is 7. Okay, so let us take it over there. And hypotenuse is 25. Okay, so we have already got, but we don't have any units, so we'll just write the value k. Okay, now we can find out the length of BC. So we will write the Pythagoras theorem first. AC square is equal to BC square plus AB square, and let us substitute the values. Okay, so here we have AC is the hypotenuse, so 25k the whole square, and BC is something that I need to find out, so I will write as it is, and AB is equal to 7k the whole square. Okay, now what is square of 25? And for all those students who already know square root of squares of 25, good. For those who don't know, can learn this simple trick to learn squares. Okay, so what I have to do is simple. Okay, 5 square 25, you already know it. Okay, so 15 square is what I want to find out. So in this case, what will happen is 5 square is 25. After 1, the next number that you all know is 2, right? So 1 multiplied by 2 is 2. So square of 15 will nothing be 225. Okay, let us try another one. So 25 square. 5 square is 25. After 2 comes 3. So 2, 3 is 6, right? So it will become 625. Let's try another one. 35 square. So 5 square will become 25. After 3 comes 4, and 3 4s is 12. So it will become 1225. Okay, and you want to try one more, then you can think of this, and I'm sure you got an answer already, and that is 4 5 will become 20, and it will become 2025. So this is the way you can find out square of a number which is ending with 5. So next time you are with your friends, you can just show off a little bit that you know squares of big numbers. You can try for 55 and 65 and all those numbers. So this is just for a tip. And here, so 25 square now will become 2 3s are 6, and it will become 625. So here, okay. Will this method work for all all the numbers? No, it doesn't work. Okay, it works only for squares of numbers which are ending with 5. And that is what I was telling initially, right? Education is not about learning of facts, but training how to think. So there. So 625k squared is equal to BC square plus 7 square will become 49k square. Now we'll get thinking of them as chocolates, get them on one side, subtract them, and let's give a little space, and 49k square, bring it on this side, will become minus 49k square. Okay, minus it, I will get this as 576k square. Now I need to find out square root of 576. Okay, because we are asked to find out the length of BC and not BC square. So we'll put a root sign here, and now you will wonder that I can tell you that it is 24, but you will also wonder like how is it possible that Sara kitna kota, how it is 24. So there's a simple idea that you can use. You have already learned methods how to find square roots, but especially in Pythagoras theorem, these numbers, right, whenever it is a Pythagorean triangle, right angle triangle, and those three sides of those triangle values will be called as Pythagorean triplets. Okay, they have some relationship, and the relationship is like this. If you Google Pythagorean triplets, you'll get a list of them, and if you notice all those numbers, okay, initially most of them, okay, not all, most of them will have hypotenuse is the longest side of the triangle. We already know it, so hypotenuse, the longest side. Then the other two sides, the arms, right, can be either equal or they can be different, right? So normally when we are considering they are different, the longest side will be, this is hypotenuse, okay, this is hypotenuse, longest side is over here. The shorter side will be way below. So if at all we are looking at this triangle now, hypotenuse is 25 and the other value that is given to us is 7. Is it close to 25 or is it very, below 25? It's low, right? So this number, that the other side which is there, will be very close to 25. But it can't cross 25, or rather 25 square, that is 525. So there are chances it can be 24, it can be 23, it can be 22, and so on. But it can't cross, be close to 7. So keeping this thing in mind, that it is close to hypotenuse, all I will do is think of 24 first. So 4 square is 16, which is, if you look at 576, right, ending number is 6 over there. So, and 4 square becomes 16, so ending number is 6 again. So there are chances that 24 square can be 576. So all you have to do is just do a multiplication check and find out. But you definitely got a quick observation of what could be the number. But if you take as 23, squaring 3 and 3 will become 9, which is not possible over here, because 5, 7, 6, right? If it was 5, 7, 9, I could think of it as 70 or 23. I hope this, you have some idea. If you're still confused, what is this sir talking, and then just rewind this video and watch it a little bit again. So you'll be able to understand. Hypotenuse, longer side, and the shorter side. So there is a difference. So if at all you are given the other two sides, then you know the hypotenuse will be close to this bigger number. I hope this is clear. Okay, and if at all the hypotenuse is given and the longer side is given, these numbers are closer. So there are possibility that the other number will be way lower to that. So just don't keep multiplying and checking. Because I've seen students, they write 1, 2, 3 and then keep doing the squares, so wasting a lot of time. So use your mind just to go about with it. So root of 576 will be 24k, and which will be equal to BC. So since I have already found out the length of BC, let me put it over there, and then that's how I got 24k. Okay. Next, what we are going to find out is the length of BC we have done, cot C. So let us look at the table now, and where is cot? Right down there, right? So cot is nothing but inverse of 10, which will be adjacent upon opposite, because it is cot, right? So we are going from down. So adjacent upon opposite. So all I will do is write that. So but where are we looking from? We are looking from point C. So let us mark the angle. Okay. So from C, when I look, my adjacent will be 24k and my opposite will be 7k upon that. Okay. K and k will get cancelled, and what I will get is cot C is nothing but 24 upon 7. Next, what we have to find out is cosec A. Now, to find out cosec A, cosec is nothing but hypotenuse upon opposite. So let us write that thing down. So cosec A is hypotenuse upon opposite. Where are we looking from? We are looking from not C this time, but from angle A. So when you look from angle A, I would advise you initially when you start solving those problems, you can use your other finger and place it over there to notice where exactly you're looking from, because students tend to make a mistake and write any ratios. So they know the ratios, right, but they look from a different angle, and that's when there are errors. So you can keep your finger and then look at it. So we are looking from A. So when I do that, my hypotenuse is 25. Okay, so I'll just write the thing down. So 25k upon 24k. Okay, and k and k will get cancelled, and what I will get is 25 upon 24. Again, I hope this problem is clear. If you understood, then you can take a screenshot and then go ahead with it. Or if you have a doubt, then the channel link is over there. You can get in touch with me and ask questions, whatever you have. So what are we doing? First we are finding the side by using Pythagoras theorem, and then we are finding the other ratios. And if you have understood these two problems perfectly, then I guess you can try solving this problem after you have watched this entire video. So in triangle PQR, angle Q is 90 degrees. If 12 cot P is equal to 5, then find the length of PR, sec R and sin P. So here you're not given the ratio directly. So all you have to do is that 12 is multiplied, right? So if you take it on the other side of equal to, it will get divided. So technically I should get cot P is equal to 5 upon 12. So I will write that part, that cot P is equal to 5 upon 12, and follow the exact same procedure. Then in triangle PAN, angle A is equal to 90 degrees, cos P is equal to 8 upon 17, then find the length of AN, cosec PN, cot N. So you can do that. Please mark the 90 degree angle first and then the other angle, the other sides. Okay, and you can try this. In triangle FED, angle E is 90, cos D is root 3 upon 2, then find tan square F plus sin square D. Now what do you have to do over here? Simple, same procedure. Find out the one side of the triangle by using Pythagoras theorem. Once you are done with that, I will just find out tan F, whatever the value is. Once I would finish normally tan F, I will square whatever answer I get. So say for example, I was getting my answer tan F to be 1 upon 2. Just an example, 1 upon 2. Then tan square F will be 1 square will become 1 and 2 square will become 4. So it will become tan square F will become 1 upon 4. And say my value of sin D was 2 upon 3. So sin square D will become 4 upon 9. Okay, so do that and just add those two values and the answer is there. Okay, so this is a different kind of a problem. Sometimes it is asked, I can't remember which question paper it was there, but it was asked in one of the papers, so know how to solve this. I hope this entire video was very clear with regards to introduction to trigonometry. What are the things that you need to keep in mind is, first of all, we are dealing with a right angle triangle. Locate the right angle, then find out what is hypotenuse, which is the adjacent side, which is the opposite side. Know that there are 6 trigonometric functions: sine, cos, tan, cot, sec, cosec, and the sides that are related. I've already told you how to remember them. Know that much and you'll be able to solve this simple problem. And we will continue in the next class some more little information about trigonometry. Thank you very much.